Hello students, in this video we'll see the derivation of the Maclaurin series of e to the x. So our Maclaurin series has the form f of x is the sum, n goes from 0 to infinity, of f n 0 over n factorial times x to the power n. And so, in order to compute these Maclaurin series, I need to do two things. I need to find the formula for the nth derivative at 0, and I need to find the region in which this converges. So there's two things to do. We need a formula for the nth derivative at 0, and then we need the region of convergence. So, let's consider an example. If I look at f of x, which is e to the x, then f prime of x is e to the x, f double prime of x is e to the x, and so on forever. The nth derivative of this function at x is just e to the x. All the derivatives of e to the x are e to the x. Therefore, if we plug in 0 into any of these functions, we will have e to the 0 or just 1. So we see that all of these derivatives evaluated at the origin are equal to 1. So our Maclaurin series for e to the x is as follows. So e to the x will be the sum. N goes from 0 to infinity of 1 over n factorial x to the n. Or you can write this as the sum. N goes from 0 to infinity of x to the n over n factorial. And now, that's the first part. The next part is I need the domain of convergence. So let's look at the ratio test. So if I look at the limit as n goes to infinity of the n plus first term in my sequence, xn plus 1 over n plus 1 factorial over x to the n over n factorial, I needed this to be less than 1. Well, the x to the n's are going to cancel. I just have an x over here, so we can pull out that x. So what we have x, and then the limit as n goes to infinity of n factorial over n plus 1 factorial. Now, n factorial over n plus 1 factorial is just 1 over 1 plus n. So I need this limit to be less than 1. Well, this limit is equal to 0 no matter what x is. So I have x times 0 less than 1. And so that just says I need 0 less than 1, and this is always true. So the range of convergence for this is all real x. So this converges for all x. Or sometimes you're going to absolutely have x less than infinity. So that's the Maclaurin expansion for e to the x. Now this gives us some useful information. So for example, if I was asked, so we'll see a consequence of this. If I was asked, for example, to find the sum, n goes from 0 to infinity, of the natural log of 2 to the power n over n factorial, we see that x to the n over n factorial added up from 1 to infinity is e to the x. So this infinite series looks like e to the natural log of 2, which is just 2. So we can evaluate this infinite series like this. Another example would be if I said, what's the sum from 1 to infinity of 1 over n factorial? Well, we have to use the convention here that 0 factorial is equal to 1. And so we're going to use this convention that 0 factorial is equal to 1. And so I'm missing a 0 factorial over here. So what I'll do is I'll write this as the sum n goes from 0 to infinity, 1 over n factorial. And then I've added in one term to this series. I've added in the 1 over 0 factorial, so I have to subtract off 1 over 0 factorial. Now this over here, I can put an n on the 1, because 1 to the n is just equal to 1. And so this series in the box converges to e to the 1 power. And then I have a minus 1. So e minus 1 is the sum of the series 1 over n factorial, where you start at 1. Thank you very much.